Hello everyone, and welcome to our presentation on magnetic-based storage technology. My name is Javier Soler, and my other groupmates are Alfred Oliquino and Juancho Soriano. Alright, let's get right into it. So, what is a storage device? Storage devices, also known as storage media or storage medium, is any hardware capable of holding information either temporarily or permanently. This picture on your screen right now is an example of a SanDisk Cruiser Micro 4GB USB 2.0 flash drive, an external storage device known as a solid-state storage device. There are two types of storage devices used with computers: a primary storage device, such as a RAM, and a secondary storage device, such as a hard drive. Secondary storage can be removable, internal, or external. Today, magnetic storage is one of the most common types of storage used with computers. This type of storage is mostly on HDDs or hard disk drives. Some of the other more commonly known examples of it are floppy diskettes, hard drives, magnetic strips, and tape cassettes. Magnetic storage, also known as magnetic recording, is the storage of data on a magnetic medium. Magnetic data storage is a key component of computer operation. This depends on the ability of magnets to magnetize to other materials and the ability of those materials to retain their magnetization until forced to change again to another magnetic field. Alright, now let's go over a brief history of the technology. Magnetic storage media are the successors of storage media, being introduced and popularized after the age of paper-based storage technologies such as the punch card. The first of many magnetic storage devices to come was the drum memory, invented by Austrian developer Gustav Tauschek in 1932. This device composed of a metal drum or cylinder with a ferromagnetic coat. This device has stationary read-write heads that await for the desired data to come around as the drum spun rapidly. This invention soon paved the way for inventors to create the hard disk drive, or HDD, and is seen as the drum's modern equivalent. The next device to be discussed will be magnetic tape storage, the start of which actually predates that of the drum memory computers. In 1928, an engineer by the name of Fritz Flümer developed it primarily for the use of audio storage. Its use in data storage soon came after in 1950, after UNIVAC investors John Mauchly and J. Presper Eckert chose it to be the storage medium to be used for the UNIVAC 1 computer. It had two distinct types of input-output devices, which included an operator's console and multiple Uniservo tape drives. Although first introduced long ago, magnetic tape is still used nowadays, mainly for the purpose of backup and recovery. Around the same time period during the 1950s, the magnetic core memory rose to popularity. Core memory was composed of tiny, donut-shaped magnets called ferrite cores, which were strung onto wires. It was handmade and, due to the tiny size of its components, required a microscope and steady precision to be manufactured. Unlike the other forms of magnetic storage made at the time, core memory did not make use of any moving parts, resulting in quicker speed. Because it was faster than its competitors, it quickly swept away from other competing technologies, being the primary way that computers read, wrote, and stored memory up to the 70s. There are many investors associated with the development of core memory, but the most notable are Harvard physicist Anne Wang, who filed for his patent in 1949, RCA's Jan Rachman in 1950, and MIT's J. Forrester in 1951. After years of ownership disputes, IBM paid a whopping $13 million for the rights to J. Forrester's patent, the largest patent settlement of that time. A similar magnetic storage media called the twistor memory was created by Bell Labs researcher Andrew Bobeck in the late 60s. It weighed less than core memory, required less current, and was cheaper to produce as it was manufactured using automation rather than labor. It, alongside another magnetic storage invention called bubble memory, had a short lifespan due to the introduction of faster semiconductor memory. The history of magnetic disk drive is a long one, and the modern hard disk drive has come a long way from its humble beginnings. IBM developed the first hard disk-based computer called RAMAC 350, and its storage, the IBM 350, back in 1956. The IBM 350 was described to be the size of 2 refrigerators, and together with the computer required an entire room to operate. Despite its large size, it was only able to contain less than 5 megabytes of data, which was already considered a lot at the time. IBM's customers had to shell out thousands of dollars to be able to install and use these large systems for a month. However, the demand for a more compact way to store large amounts of data began to rise. This prompted IBM to create one of the earliest forms of removable storage called disk packs. Devices such as the IBM 1311 made use of these packs, which allowed their customers to be able to expand their storage by an approximate 2 megabyte per disk pack. Up to that point in time, computers were both huge and expensive, its users ranging from universities, big businesses, and government institutions. The price fall of electronic components coupled with the density of memory chips during the 1970s, however, ushered in a brand new industry revolving around personal or home computers. With this, IBM began focusing on another magnetic storage device, the floppy disk. Made of thin flexible plastic and casing magnetic film. It was not only cheap, but portable as well, making it a popular choice at the time. Like hard drive technology, the floppy disk would decrease in size over the course of its lifetime, from 8 inches down to 3.5 inches, to benefit those using personal computers. Floppy disks, however, died down after the introduction of newer storage technologies such as improved hard drives and CDs. Hard drive technology, on the other hand, would flourish even up to this day, exhibiting a major downscale in size, but a continuous increase in storage capacity throughout its lifespan. Well, enough for the history lesson. Now let's talk about how it works. Information is written to and read from the storage medium as it moves past devices called read and write heads that operate very close, often tens of nanometers, over the magnetic surface. The read and write head is used to detect and modify the magnetization of the material immediately under it. There are 2 magnetic polarities, each of which is used to represent either 0 or 1. Well, that's basically about it for how it works. Or at least that's a simple explanation of how it works. But anyways, let's move on to some key features. Although a solid-state drive, or an SSD, has multiple advantages over the traditional hard disk drive, recovering data from a solid-state drive is more difficult than a hard disk drive. Okay, so let me explain that. Let's compare the two. If you've lost data from SSDs and HDDs due to any reason, it's possible to recover the data. However, the level of complexity differs. It's more difficult to locate data on SSD for recovery. On the mechanical hard disk drive, data is passed from the controller to the disks magnetically and written to the drive as bits on the platter. Therefore, to read the data, just return to the same location and read magnetic orientation of the bit. In comparison, solid-state drives store data more complexly. So as to block flash chips from wear and tear, the location of data stored is always changing. Therefore, in data recovery, it is more difficult to locate the data on solid-state drive. Though in recent years, solid-state drives have become increasingly popular, there is still less systematic knowledge than that of hard disk drives. There's no denying that the hard disk drive has taken up the data storage market for a long time. So, there are far more data recovery experiences, skills, data extraction tools, and specialized knowledge about hard disk drives. Therefore, recovering data on hard disk drives is generally easier than solid-state drive. Okay, now that that's done, let's talk about development from previous generations. Through the years, developments in magnetic recording took place from being a machine that was heavy, expensive, and difficult to operate to a smaller and more cost-efficient product. Alright, well, now let's talk about the future. For high-capacity storage, hard disk drives are the cheapest option per megabyte of storage space. The only alternative storage option if you need high-capacity internal or external storage is a solid-state drive, a form of flash memory. However, solid-state drives cost 5 to 10 times as much as a hard disk drive of the same capacity. Based on the data collected by McCallum and Block, the cost of manufacturing HDDs are getting cheaper and cheaper. magnetic recording probably is the cheapest form of storage per megabyte of storage. Here's a chart that shows the linear scale of how much USD per gigabyte costs per year. Pause the video if you need to. Alright, lastly, let's talk about implementation. Magnetic devices, such as hard disk drives, use magnetic fields to magnetize tiny, individual sections of a metal spinning disk. Each tiny section represents 1 bit. A magnetized section represents a binary 1, and the demagnetized section represents a binary 0. These sections are so tiny that disks can contain terabytes of data. As the disk is spinning, a read-write head moves across the surface. To write data, head magnetizes or demagnetizes a section of the disk that is spinning under it. To read data, the head makes a note of whether the section is magnetized or not. Magnetic devices are fairly cheap, high in capacity, and durable. However, they are susceptible to damage if dropped. They are also vulnerable to magnetic fields. A strong magnet might possibly erase the data the device holds. As of 2011, common uses of magnetic storage media are for computer data mass storage on hard disks and the recording of analog audio and video works on analog tape. Since much of audio and video production is moving to digital systems, the usage of hard disks is expected to increase at the expense of analog tape. Digital tape and tape libraries are popular for high-capacity data storage of archives and backups. Floppy disks can still see some marginal usage, particularly in dealing with older computer systems and software. Magnetic storage is also widely used in some specific applications, such as bank checks in their MICR line and credit or debit cards in their mag stripes. Thank you for watching, and we hope that you learned something. On behalf of my group, this was our presentation on magnetic-based storage technology.